Hello, we are back. It's the Meon science in action. We are going to talk about redox reactions. Redox reactions. The redox, as we know, it's an acronym which refers to the reduction, and the ox is for oxidation. Now, oxidation in the olden days, it was perceived as when any substance reacts in oxygen, it undergoes oxidation. So oxidation was just when a substance reacts with oxygen, then it's oxidized. So, but now oxidation is no longer like that. We'll give you an example. Reduction in simple terms is just in terms of oxidation numbers, it will be an increase in oxidation numbers, a decrease in oxidation number, we'll draw the number line for that. And then also oxidation is an increase in oxidation number. Therefore, if we draw a number line, you know this one in maths, 0 is there in the middle, the right hand side is positive, this one is negative. If I move from 2 to 0, I say the number is reduced, that is the reduction. And now if I move from 0 to maybe 3 in this case, therefore that's the opposite of that reduction, will be oxidation. Now the other definition for oxidation and reduction is that reduction, if you explain it in terms of electron transfer, it will mean the gaining of electrons, whereas oxidation will be the loss of electrons. Now let's talk about an example where these two reactions takes place. Let's take a simple one. When magnesium is reacting with chlorine gas, it will be forming the compound magnesium chloride. Now if we ionize the equation, then it will mean that magnesium plus the chlorine gas will form magnesium ion plus 2 chlorine ions. If we track the change in oxidation numbers, because this is a redox reaction, magnesium changes from 0 to +2, which is an increase in oxidation number. Therefore, it means that this is magnesium is oxidized. And then chlorine changes from 0 to -1. If you look at the number line, if you move from 0 to -1, you're going the left hand side. Therefore, that is reduction. Therefore, if we now split this into 2 half reactions, then just to show the change in magnesium changes from Mg to Mg2 plus, whereas chlorine gas changes from chlorine to 2Cl minus. If we balance these half reactions, in terms of using electrons, then it will mean this side there is no charge. Also this side should not have any charge. We've got positive, then we'll have to add 2 electrons. This side, this is 2 negative, whereas this one is no charge, therefore we'll need to add 2 electrons so that we can have 2 negatives, 2 negatives. It's balanced. Now, because we said magnesium is oxidized, therefore this one will be the oxidation half reaction. Half reaction. Whereas in the case of chlorine, it is now there's undergoing the decrease in oxidation number, therefore this is reduction half reaction. Half reaction. Therefore, if I add the 2 half reactions, if I'm writing what we call the overall reaction or the net reaction, it will mean that now I add the 2 half reactions. When I'm writing the overall net reaction, I always use the electrons to balance. Therefore, in the first half reaction, I've got 2 electrons on the right hand side, whereas in the second, I've got 2 electrons on the left hand side. So the number of electrons are balanced. Then obviously they will cancel out. And then on the left hand side of the arrow, in the first one I've got Mg, in the second one